The Pythagorean relationship is a relationship between the sides of a right-angled triangle. The Pythagorean relationship simply says this: the square of the longest side of a right-angled triangle, which we call the hypotenuse, is equal to the sum of the squares of the two sides. This means that I can find any side of a right-angled triangle if I know the measures of the other two sides. We will demonstrate this using a few examples. In using the Pythagorean relationship, we simply go back to our idea of algebra. In the Pythagorean relationship, the formula says a squared plus b squared equals c squared. Therefore, remember that a is any one of those sides. So if this is a, then here must be b, and then c would be the longest side or the hypotenuse. So if I am to use my formula to find here, because this is the part that's missing, I simply substitute the numbers into my formula. So I could assume that, let's say 12 is a, so a could either be 12 or 5, it doesn't make a difference. So let's say that a is 12, so I would do 12, my formula say 12a squared, so 12 squared, plus b, which will be the next side here, 5 squared, should be equal to the hypotenuse, which I don't know, squared. So I'll leave it as c squared. And from here, it's just a matter of trying to solve for c. In this case, I work it out. 12 squared is 144, plus 5 squared, which is 25. That should be equal to c squared. Calculating, continue calculating, simplify my problem. 144 plus 25 gives me 169. 169 is c squared. But notice this side is simply c. So I want to know c times c gives me 169. So what is 169? That brings us back to our square root. So what is c? That brings us back to our square root. So to find c, I would simply do the opposite of squaring c, which is finding the square root of 169. The square root of 169 is 13. Therefore, this side of my triangle is 13 centimeters. Simply use the Pythagorean relationship with some algebra in order to figure out the missing side. Another demonstration here, another example here. Again, our formula says a squared plus b squared would be equal to c squared. In this case, what is missing? C is missing, the longest side, the hypotenuse. So again, I could assume that here is a, I could assume that here is b, and then just fill in my formula. If 3 is a, then I would fill in 3 squared plus 4 squared should be equal to missing side c squared. As much algebra as I can, simplify it as much as I can. 9 becomes here because 3 to the power of 2 is 9, plus 4 to the power of 2 gives me 16. This should give me c squared. Again, simplify as much as I can. That becomes 25. 25 is c squared. If 25 is c squared, if I need to find c, c would simply be the square root of 25, which is 5. Therefore, my missing side here, c, would simply be 5 centimeters. Straight use of the Pythagorean relationship formula. Here's another example. And in this case, notice what happens in our example. In this example, we are given the longest side already, and we are asked to find b. But it shouldn't be a problem. Simply substitute into our formula. Our formula says a squared plus b squared gives me c squared. Again, remember, a or b is always one of those sides, but it told me that here is b, so I can assume that this is a. C is always the longest side. So a would be 6. So 6 squared plus b squared. I don't know what b is, so I leave b as b squared in my formula. This should be equal to c squared. C is 10. 10 squared. And from here, I do my algebra to find my missing letter B. Simplify as much as I can. 6 squared becomes 36 plus B squared equals 10 squared becomes 100. Again, remember algebra, we want to get the letter by itself. So if I'm to get this letter by itself, I need to subtract 36 on both sides. This means B squared would be equal to 100 minus 36. Again, to get B by itself, I subtract 36 here, so I subtract 36 here. That means B squared is equal to 64. Notice again, B squared is 64. So if I need B, I find the square root of 64. Remember, the square root of a number means what number multiplied by itself will give me 64? 8. Therefore, B is 8. My missing side B is 8. So using the Pythagorean relationship simply brings us back to algebra to solve and use a formula.